Once people are born in space, they are in one way or another aliens. What is their currency? Will oxygen be their currency? How would it look like to have a first baby born in space? The daycare, the education, how the parents behave. These are all philosophical questions that needs to be answered before exploring how it would look like. But it's still a fascinating mental exercise to think about.
In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipf, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. So, Omar, as the founder of Future Space Architecture, FSA, your mission is to accelerate the expansion of human civilization beyond Earth through developing the world's first in-orbit logistic spacecraft. Tell me, why do we need that?
Oh, that's an excellent question. Thanks for asking me. First of all, thanks for having me on this podcast. I'm looking forward to our conversation. The reason we need this logistics in space is because we're reaching a pivotal point in the space industry where we could reach into a backlog or a bottleneck while dealing with the logistics and operation in orbit. So up until now, according to the FAA regulations, around 300 operations are going to be projected to be launched into space in 2027, compared to around 70 in 2022. That's a big increase. And most of this is used by SpaceX. And SpaceX, 60% of the operation that launches into space for SpaceX are related to Starlink, their own satellite systems. This can grow for a good while, for 4 or 5 years. But at one point, there's going to be saturation. And then SpaceX will need more clients and cargo to bring into space. And by that time, it's expected by 2035 to have around 2,000 tons of cargo launched into space monthly. That's the capacity. So what do we do with all the cargo in space? We can't just we need centers to collect the data, the cargo, and distribute it in orbit for us to have any proper approach to building projects in orbit. Yeah, so that's in a nutshell why we need space logistics.
And what kind of operations or cargo are we talking about?
So far, all the cargo that is transported into space to International Space Station or satellites are already pre-built on Earth using Earth resources and then assembled on Earth and sent into space. For any meaningful in-orbit operation to happen, in-orbit economy, that means in-orbit manufacturing, we need raw material to be present in space, and we need a smooth distribution of resources in orbit so that any project, any company that is investing to do a project in space needs a guarantee that there is a smooth access to the resources on a timely basis. And that's only according to our experiences on Earth, that's only satisfied by having storage and logistics systems, distribution centers, and last mile delivery systems that guarantee your order or your needs are always on time and accessible and stored in the vicinity of your operation. And to do that on Earth and send it every time you need something to send it into space, that's going to really restrict what we can build in space and what we can operate in space. So what we are doing, what FSA is doing, is to provide the infrastructure to have the storage capacity and the logistics to manage cargo by third parties stored and delivered by FSA. in space.
So it's like an Amazon for space products.
It is kind of an Amazon, and it's partially Amazon, partially DHL. The most important thing we aim for is to provide space for third parties, for entrepreneurs to utilize that space, and they do their own business within our storage areas and service other companies. And by doing that, we also allow younger entrepreneurs to dream about projects that they can use and build in orbit that because of the unavailability of access to cargo and resources and raw material, it would not happen now.
Very interesting. So I want to go deeper into opportunities for businesses in space and into the whole construction of your spaceship, let's say. But first of all, if we talk about space, do you believe in Mars? And if so, how does the prospect of life on Mars influence your plans?
What Elon Musk is trying to do by making sure that humanity has a second basket. It's not all eggs in one planet, it's on another planet. And I think that's a very noble thought, what he's trying to do. But also from my perspective, he started the way, and we need to think for the next generation of innovators. We need to build on what he is doing, because from my perspective, knowing that we are closer to be able to send ships to Mars, at least cargo and robotics to Mars, not humans yet. Well, we are basically what we're ending up doing is building space rafts that we're only taking something from Earth and bringing it to Mars, dropping them there, and hoping that they will not repeat the mistakes that, first of all, hoping that everybody survives, and second, that they do not repeat the same mistakes and have the same conflicts we have here on Earth. So, setting aside all the challenges of working in the Martian atmosphere and Martian climate and utilizing Mars's resources. So that's it. But what I believe more, which is a harder challenge, but it's a longer term challenge, is for us to be able to master living in zero gravity, living in orbit. That way, we can create ecosystems and colonies in space around planets, and will hopefully in 100 years allow us to do interstellar travel, because we will not be able to travel to other planets further away from Mars, like Jupiter, because or go outside of our solar system in, I don't know, 150 years, 200 years, if we don't master or conquer microgravity, the challenges that microgravity and the vacuum of space holds on us. So I believe it's one of our objectives to jumpstart this approach by localizing and encouraging orbital transportation and orbital travel.
That just blew my mind. So you believe in life on Mars, but you believe in like interstellar life as well.
I hope. Why? Like we came from historically humans came from Africa, and with only two legs, we traveled continents and traveled seas and oceans, and we created wagons and trains and moved further away. And now we're building rockets and we're going into space and into the moon and hopefully to Mars. And to say at the end of the day we stop at Mars and we just settle there, I think that's something I'm not willing to accept. I think we need to go further and try to develop the technology to do that. Maybe we'll never in our lifetime achieve that, but we put this first brick for our next generation, our kids and our grandkids, to have this opportunity.
That's a huge vision and mission. So Omar, tell me your story. How did you get from managing large-scale architectural projects on Earth to founding future space architecture?
Yeah, my story is nonlinear. So there is a lot of zigzagging happening. But it's if I want to trace the critical path, the milestones on the critical path, it starts. There's 3 phases. Where first of my childhood, I grew up. My mom was a head librarian of the private school which I studied in. And when everybody went home, I went to a high school, and I went to my mom, waiting her to finish her work, and just got lost in the library reading books. And one of the landmark books that influenced me now is called Rendezvous with Rama by Arthur C. Clarke. And it's about a interstellar spacecraft that comes into our solar system, and how we explore it, and the idea of the first time of aliens, and how it's like an O'Neill cylinder, and exploring it from the inside. So this really drove through it. It itched in my brain this thing that maybe it's possible, especially that Arthur C. Clarke has a history of predicting science, like science fiction into fiction. He's the first one who predicted that we will use, in 1947, that we will use satellites for communication. And only in 1957, I think, Sputnik 1 became a first human satellite in orbit. So I really believe there's something going there. The next thing is my education and my experience. My dad is also an architect, so he really gave me, like, pushed the soul of an architect, like at home and all those things. And I got exposed to Frank Lloyd Wright, not just because he's the father of modern architecture, but also his story, his tragedies and how he overcame them, his personal and affected his architecture, how he revolted against his mentor, because Sullivan, because form follows function, and then Frank Lloyd Wright said form and function work in union. And he was so much influenced by other culture, like Japanese culture and so on. So that allowed me, once I finished university, to make a conscious decision to experience the full spectrum of being an architect. So I became what I called a traveling architect. I lived and worked in 7 countries, over 4 continents, worked on absolutely big, large, and amazing projects like airports, hospitals, universities, High-Rise Tower in Toronto. And this made my experience very colorful and dynamic. And then questions start rising, especially when you're 40. So what is my purpose? What is my why? How do I want to make an impact, a significant impact? And when I had this phase where I'm trying to figure this out, and when everything settled down, the story of Rendezvous with Rama and the spacecraft and the spaceships and colonies in space and interstellar travel just wouldn't leave me alone. So transitioning from an architect to a space architect was a no-brainer for me. And but then started a different journey, because now I have to learn from wanting to become an architect to learning what it takes to be a space architect, to starting the startup and doing my designing the spacecraft. That's also a very condensed 5-year journey, but it's also very, very dynamic and very non-linear.
Wow, that's a crazy story.
Yeah.
So talking about your spaceship, I'm an architect and most of our listeners are architects. Could you explain how the structural design process and the construction process of your spacecraft looks like?
Okay, this is part of the non-linear path that I took. I didn't start designing a spaceship. I started designing a space station. So I studied.
What's the difference?
The space station doesn't have propulsion, so it's kind of in a cruising constant fall around Earth, so like the International Space Station, and it needs a spacecraft to every 3 months to 6 months to reboost it, raise the altitude of the spacecraft to its original, which is around 400 kilometers. But it loses height as it's turning at a very high velocity. So that's the difference. Is the space station is just a module that is pressurized, that has a protection from the outside and a structure, but it doesn't move. It's static, at least in a respective of each other, and it's in its orbit. It's forced to move by a thrusting propulsion engines and thrusters. To me, I wasn't going too much away from what we do as architects. The design, just like any building, we have structural elements, we have insulation, we have plumbing, electrical. The only difference, which is a major difference, is that you cannot just plug your electricity to the main. You have to create your own electricity using solar power, so solar arrays or iRosa or similar means of electrical power systems. You have to store the power because it turns around the Earth every 90. It makes a full turn around the Earth every 90 minutes. So there's times where there's no sun; it's hidden on the dark side of the Earth. So that you have to. So that means we have to provide storage for power, so that when there's no light, you can the spacecraft is still operational. That when it comes to the inside, you have to provide atmosphere, because you have to imagine it just like you're building a submarine. The outside, the water, there's high pressure outside. There's and you have to make the structure and the environment separation so that the environment outside doesn't go inside. So it's similar to designing in theory, to the processes of designing structures on Earth, but in a very much higher technical and environment conditions. Plus, we have to consider the human factor, because human beings in zero gravity behave kind of differently. So how we sit, how we walk, is different in space. The space that we need to operate machines and equipment, how to move from one module to another, the openings, the hallways, they're all. But fortunately, NASA has all this information. So I didn't have to invent or reinvent anything. During this 4 years period, I dived deeply into getting any information I can about from NASA and ESA and RFIs, and I read as much documents as I can to educate myself to be able to design the spacecraft.
Are people constantly living there in the logistic spacecraft? Because you talk about people moving around and how they behave there.
Yes. So the logistics spacecraft, just to be clear, it is not. So that's part of the sustainability of operation that we believe in future space architecture. We decided to narrow the niche of our operation to a certain segment, which is logistics for cargo and raw material. That means what we're carrying, it's not going to be most of the other companies and startups that are working in space, at least, or space stations that are being designed. They cover the full range from cargo, normal storing water and storing like a normal cargo, to operating high sensitive experiments for universities, research centers. So we decided to focus on the bulky, on the no frill end, and that allows us to operate have more leeway and more autonomy for the spacecraft to operate autonomously in certain cases, and can be crewed in other circumstances. But as a general rule of thumb, we would like the spacecraft to be operated autonomously, unless we have to carry like humans as resources from one asset to another.
Okay. And you talked about the energy storage that you need for the 90 minutes that you go around the Earth, or for the dark side of the Earth. How much energy does it consume?
Well, it depends on the systems that we're using. what we are producing, our rollout solar panels, solar rollout panels that we are utilizing will be producing around 25 to 30 kilowatts of power, which is can turn the lights on a small neighborhood. So it will be more efficient. It will be sufficient to keep all the systems and life support system in the spacecraft operational.
Wow.
Yeah.
This is being so interesting. I've never talked so deeply about this topic. So, Omar, what are the biggest engineering and logistical challenges you face when constructing for space?
We have the technology to build this kind of spacecraft. But the technology is spread out into different technologies that needs to be assembled together. And that's part of the intellectual property that we're working on, that will be part of the startup. So I cannot go into too much details about what is really the pain points. They are solvable, and hopefully we will be hiring really smart people to solve those problems. But in general, propulsion is a challenge, because the idea of having a spacecraft that once deployed in orbit doesn't have to go down to space, back to Earth, and then has to have a lifespan of at least 15 to 20 years. That's a challenge, especially that thrusters have a shorter lifespan than that. They operate by like 1,000 ignitions or 10,000 ignitions, depending on the thruster. Sometimes some of them are 5 ignitions, and then the thruster is dead. So those are challenges that we're facing, and we're trying to solve. One thing that I'm I've heard colleagues of mine, like other CEOs that are and entrepreneurs facing, is especially in Europe, is the human resources are a bit scarcer than that of the US, because they are ahead of us. So people are already pre-trained on different systems in the US and are graduated from different startups and moved on. But here we're still a little bit we're growing. There's like I'm collaborating part of the TUM Venture Lab, and hopefully we'll utilize TUM's human students and resources. But it's an uphill battle but the talent is there. Like the motivation, the people are so much motivated. It just takes some time.
Are there any other collaborations with companies or governments or educational institutions that are helping you?
I cannot disclose at this point so much, but it's growing. It's like we're getting attention, we're getting recognized, but it's an uphill battle, because the idea of space logistics is not so much yet in the public eye for investors or agencies. They're more focused on low Earth orbit satellites, and they're hoping to build a space superhighway. But so we're more in the phase of messaging and showing people that we need space logistics. We need in-orbit logistics, in-orbit storage facilities, last-mile delivery services. And that's what we're trying to show for the next couple of months.
The role of any startup to educate people first, right?
Yeah. Most of the people we talk to are already super educated and super smart, but they are limited by the only thing that is is that when agencies give grants, then they push the trajectory of innovation and entrepreneurship in one direction, and everybody starts thinking, okay, how can I get this grant? So I limit. And now I'm trying to say, okay, let's look at bigger opportunities that we can move the sector into. But I'm not the only one doing that. There's a lot of other organizations and companies, like the exploration company in Munich, also, and a rocket factory. So there's a lot of things happening that are making innovations in the space sector. But I'm trying to do my part.
A few of you might know that I recently opened my own architecture studio, and I just started with the podcast. I'm very excited to build a platform where I connect with inspiring people to learn along the way and share these learnings with you. So if any little thing has inspired you, or if you learned anything new, I'd appreciate if you could rate the show or share my content on social media, Spotify or YouTube or wherever you listen to it. And if you think there are any touch points between you and me, I'd be super happy to connect with you. Feel free to reach out on any platform. With the space sector growing, what opportunities do you see for new businesses and industries in this expanding market?
Tons. There's going to be So imagine a town that every 6 months for 2 days, a town on a mountain that in the top of the Alps or whatever, isolated. Only 6 days a year, a path opens up, and you can bring in cargo in and out. That's what we are. That's the situation here. So imagine if you can have storages, and so that you can have their all year round needs plus surplus are inside this town, and they don't have to rely on all deliveries. Then suddenly everything will bloom. People will go in and they will do their own businesses that the people of that town haven't even thought about. So we can talk about in space manufacturing, whether parts for welding and metal to build structures, or manufacturing of medicine, because in space there's advantages for molecular cohesion, and that will help in the building of new types of medications and improved versions of medications. You can talk about solar farms. We can talk about this is also the kind of a midterm sustainability thing that we're hoping to encourage, is that once you have this infrastructure, then people can stop relying on or take the first step from relying on Earth resources to operate space projects. So maybe in 15 years, a young entrepreneurs or a consortium will use our infrastructure and start mining outside in our neighborhood for material, and then bringing it and using that to operate projects in space. And then that will also release Earth from utilizing so much resources outside of Earth. And we can also utilize it to bring those resources back to Earth. So there's tons of opportunities.
I recently saw a company that is focusing on building housing and stuff on Mars, I think. And they also say that instead of working with Earth building materials that we use on Earth and bringing them up to space, they are trying to, they are doing a lot of research on 3D printing with materials that you find on Mars. So they don't depend that much on systems like these.
Yeah, this is called in situ resource utilization. And this is now being the research is more now happening for the moon, especially that they're able to find in the South Pole water, and they can utilize, there's iron on the moon, which they can, using abundance of iron and oxygen through iron oxide. In the moon's regolith, there's around 45% by weight oxygen, which can also, and there's a lot of hydrogen, which can be utilized for rocket fuel. So if a ship lands, they can utilize the resources on the moon to refill their rockets and leave the moon somewhere else. Or if they want to fill up a spaceship that want to go to Mars with a pit stop on the moon. So this research is happening now, and it's going to be part of the Artemis program, which is coming up in which is supposedly happening the next 6-7 years. Orion spacecraft the last year went to the moon and back. That's part of the first phase of the Artemis program. And now there's phase 2 and phase 3, which is taking people to the moon. And they're going to be dropping robotics to start experimenting with regolith and extraction of resources from the regolith on the moon. And that will build for Mars.
Have you ever been to space?
No. The freest I've been was I took classes flying a Cessna in Toronto. That's the freest I've been. And then my teacher also did some like dives where you experience zero gravity in the Cessna, which is amazing.
Oh wow!
Yeah, but that's the furthest I've been to zero gravity.
Do you think you'll ever get there, or is that not like a dream of yours?
No, of course. Oh, I'm hoping that in 20 years, we can have tourists go around the moon. I'm not sure about landing on the moon, but do a round trip around the moon and come back.
Oh wow, that would be wonderful.
I'm hoping that. But this is also our linear perspective of progress. So if you take, we haven't factored in AI. Like if we achieve, the AI is getting exponential, and utilizing the exponential growth of AI to improve our technologies, this could also have an exponential growth in technology and shortens the time spans. But from my perspective, in a linear way, in 2040 we can have tours around the moon and come back if we wanted that.
Wow.
Yeah.
So what role does AI have to manage in-orbit operations?
At least for Eden Prime, AI is going to have a big role in several parts. And here, AI and robotics are going to be like married together, because at one phase, it's about the manufacturing, because we plan the design for Eden Prime is not. We plan to from the beginning design it to become a fleet, so mass production. So that means we have to utilize robotics and algorithms to be able, just like Tesla is doing, to do a certain variation of the unboxing concept to mass produce a safe structure and chassis and the whole vehicle as much as we can on location on Earth. Another utilization of AI is by autonomous operation. So the vehicle has to do calculations and has to do orbital maneuvers. It's unlike a space station or a space plane that goes up and down, which is still needs a lot of computing power and algorithm. But the spacecraft will stay in orbit, change orbit, and move back and forth. So that operating it will require a lot of computational power and very strong, robust algorithms. Plus, the actual operation of the Eden Prime, while connecting, berthing with other assets, collecting assets, we're using the robotic arms, doing simultaneous while adjusting its thrust, its attitude, and doing attitude control and adjusting its positioning and its alignments. These are all going to be heavily dependent on AI. There's going to be, of course, human supervision, but it's going to be very much supported by AI. So that's at least two aspects that AI and robotics will influence this design and this project. Tons of data is going to be produced by Eden Prime, and that's also have to be sorted out and categorized and assessed and reviewed. And this cannot happen. It will require a very large algorithm and sophisticated one to be able to do that.
What kind of data?
everything so every system has to be maintained, reviewed. If there's errors, if there's failures, has to be put together, connected through a hierarchy, a command and handling system, all networked together, and then has to be stored and assessed, produce reports, and come up with improvements for the next model or variation. It's a very wide range.
Okay. So going very specifically into like the construction process of Eden Prime, well, whatever you feel comfortable sharing, like what type of materials do you use and how does the construction process of the spaceship look like? I guess it's going to be built on Earth and then sent out completely finished, right?
I'm not going to go into details regarding the material science is going to be pivotal in organizing, building the structural elements and the shielding elements. But most of the idea for the spacecraft is utilizing material that are proven to be effective, like the Columbus module, the pressurized capsule is made of aluminum, certain variation of aluminum alloy. So we're not varying away from that too much. Each part of the spacecraft will have, per function, we'll decide what kind of material is going to be used. But the most important thing is we need to, from the beginning, utilize the material in a certain way that facilitates the volumetric manufacturing process, and that's the challenge. To observe safety and quality, plus manufacturing and production.
When are you planning on building the first one?
First, we were seeking funding. So that's not happened yet. So we're in that phase now. We're going to start seeking funding. But if usually I would say 6 to 8 years for the first
once
deployment.
You get the funding.
Yes, you get the funding. 6 to 8 years.
Wow, cool.
For deployment. And you asked about how we're putting it up in space. We're hoping, we're all finger crossed. We believe in Elon Musk. We believe in Starship because we're hoping that we'll utilize Starships the 22 meter, the second variation of Starship, not the current 17 meter, the 22 meter Starship to take Eden Prime up into low Earth orbit.
How big is Eden Prime?
It's 18 meter height, 18.8, sorry, and 7.1 meters in diameter.
Okay, with the wings, let's say, or without?
Well, no, without these are no wings. These are solar panels.
They look like wings.
Yeah, exactly. They do look like wings. With the solar panels fully extended, it's 43 meters.
Okay.
So
wow.
it fits. It's like a Wimbledon tennis court without the stadium, just the floor.
Okay.
The full floor of a Wimbledon tennis court.
I thought it would be bigger.
Well, 18 meters is 6 stories high.
Yeah. Like there's like nothing else, like every time you see a picture, it's like all black around. You don't have like a scale to measure. So you've talked about creating a sustainable orbital infrastructure. Could you discuss how sustainability practices on Earth might translate into space environments or how they might need to be adapted?
Well, actually, for me, maybe it's a bias, but I believe it's the other way around. I believe, and that's something a lot of people who say, why do you need to go to space? Actually, the technological advancements that we're doing through research on the International Space Station, the translation of that discoveries and technologies are translating down to Earth and helping in our sustainability, solving our sustainability issues. So all the money that is utilized to solve a problem of, let's say, environmental life support systems, where you have a closed life support system, which in the International Space Station, it was 90% of the water used by astronauts, breathed and used by astronauts, has recycled, and they brought it up to 98 using certain chemicals, and that separates the water into brine, all the chemicals and the So all of those discoveries and all of those innovations are now then translated and utilized in our systems to improve our Earth systems, to make it economically, climate-wise improvements. To give you an example, WD-40, the spray for the oil, that was made for space. It wasn't, and then it was used on Earth. There's a lot of those examples where things were designed for space because people can't afford to spend money, and then once we figured out that how helpful in very extreme environments, we took them down to Earth and utilized them. The only now challenge, which is very obvious, is the emissions and from launching rockets into space. But SpaceX kind of quieted this objection by using reusable first stage rockets. So that's a win. It's still substantial, but eventually utilizing different techniques of sending stuff to space. So there's a company, the name, I think his name is Spin or something. It spins the cargo, and utilizing the force of a spin, the centrifugal force, shoots without propulsion the projectile into space and can reach escape velocity, or hoping to reach escape velocity. That way, raw cargo can be just launched this way without burning chemicals, by using electricity and spinning to a very high speed and shooting it up into space. So there are technologies that are being considered to minimize that, and so that you have certain cargoes will utilize this, certain payloads will use a different type of approach. So yeah, I'm hopeful.
Super cool. So I have one last question for you, Omar. Sure. How do you envision daily life in space?
Yeah, that's a question I ask myself always. This is a silent question in my head, which I'm trying to figure out. How would it look like to have a first baby born in space? The daycare, the education, how the parents behave. Do we behave? Will there be same same system that we are used to here on Earth for people, where the parents take care of a kid, or it's going to be communal? These are all socio-economical, political configurations that I'm very interested to hopefully one day be able to think about more and write about. But for now, in the International Space Station, it is hard work. It's intense labor. It's 8-hour shifts. It's fun. It's amazing, but still, from what I heard from a lot of astronauts, you're constantly fixing stuff, running research for organizations that rented a spot, doing experiments on the International Space Station, going outside doing EVAs to fix something, to add an experiment or fix an antenna or add the part. It is nonstop, and a very labor and mentally demanding job.
You put like some images in my head when you were talking about the first baby born and how does daycare look like and everything. So do you imagine like, I don't know, towns or several houses on a platform floating around in orbit, or how do communities work there?
Yeah, I am not sure. Because the main reason I am not sure, I'm hesitant to answer this question and even to think about, is that for us to answer this question, in my opinion, means we might need to abandon some of our social norms that we are used to. Like a two-parent family might not work in space, in the sense that every two parents will raise parents will raise their kids, and another couple will raise another kid, and then they meet. That this is what we do in normal life. We might have one mom or one parent, one couple that raises the kids of 10, 15 people, and the others have to constantly work. And but that's also something we have to consider. There's ethical implications and thoughts about it. So it's very, I tiptoe around this. I can imagine how it is. I can project. It's easy for me to project, like sometimes they do in science fiction, our lives for a life of people in space. But we have to realize, once people are born in space or people live for an extended period of space, they are, or at least born in space, they are become in one way or another aliens, and they have to live their life the way they think it. What is their currency? How is it? Will oxygen be their currency? Will they have like US dollars? And I'm not sure about that, because what usually currency is attached to the most valued resource. For centuries, it was gold for us. That transactions with gold. Up there, what is the most highly valued currency? These are all philosophical questions that needs to be answered before going forward and exploring how it would look like. But it's still a fascinating mental exercise to think about.
I think we'll have to do another podcast about just the philosophical aspects of it.
Sure. Yeah.
Super interesting.
Interested. Yeah.
Thank you very much, Omar. I'm really looking forward to seeing more of your work. If any listener wants to follow what you do, where can they find you?
Well, they can find me at a website. It's called futurespacearchitecture.com. And then there you can have access to the to Eden Prime, about Eden Prime and the master plan. That our vision for the future and how we want to influence the logistic in space.
Great, I'll put it in the episode description.
Thank you for having me, Latina.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials at LatinaShip. Thanks.